Hello YouTube, Jerry Kirkpatrick here. I went to visit Gene Winfield at his shop in Mojave, California, and one of the projects that we did during that stay was make one of these hatch panels for a 50 Mercury two-door sedan. And while we were making that panel, I was allowed to turn the handle on the old machine that he had that created this radius on the leading edge of the panel. When we got finished turning that piece, I asked him why he wasn't using the machine that I had made for him to do that job. And it being electric, he wouldn't have to wait around to grab somebody else from his shop to turn the handle. Well, the answer to that was he didn't have a set of dies that would fit my machine, or the machine that I made for him. So that is the purpose for this video. So I said that since I have a radius turning tool, I'd be more than happy to build a set of dies that would fit my machine. So we started looking at the machine that he has with the dies on it, and then we started looking around at anything different that he might want on the new set of dies, and it was pretty straightforward. So we started drawing them up and discussing how they would be used on the machine that I made for him. So what I'll be starting with is just some 3-inch 4140. It's the same material that the radius turning tool is made out of, and I've already turned them to the correct diameter, 2.5 inches, and bored the 7/8 hole in there that fits the shaft of the bead roller. So let's get over on the lathe and start turning these things out. So it's 100 degrees in the shop right now, and if anything goes awry, I've got like a built-in excuse. So let's get started. Now my radius tool is usually just hanging up on the pegboard here alongside my knurling tool, and I keep the 2 bolts that bolts the radius tool down to the carriage along with the wrench right on a shelf just in front of the lathe. So the first thing we're going to do is take the compound off. I'm going to wipe this whole surface off up here, make sure there's nothing underneath that will be embedded into the carriage when we tighten this down. I'm going to place the T-nuts at 6 and 12 o'clock, and then position the radius tool get the bolts started. Make sure that the handle is clear. Next, I'm going to install the mandrel. Get it up fairly short. Next, we put on the blank. Get that keyway up. Slide that on. Tighten that down good and snug. Next, we're going to install the concaved cutting head. And then the adjusting guide here. You can see here that I misspoke earlier. I remembered this on center being 190, but it in fact from the center of the concave die to the convex die, center line is 100 or 1 inch 800 thousandths. That still keeps the shafts pretty much in line. And these are the dimensions that we'll be going after. We have 1/8 of an inch that we have to stay back from the back edge, and that'll allow, with the 3/4 inch radius, it'll allow the snout of the die to be 1 inch in diameter. And then here you can see that from the center to the tangent point, we are at 0 here. But if you draw the tangent line here, there's this little segment that will be left over. The radius will be coming up off camera, and after I get this finished, I'll start at this point and turn this off flat, so we'll have a slight flat in this area. So what we're after is a 3/4 inch radius in here. So we're going to come out to 750 thousandths. Tighten that up. I'm going to set my square here. At 750 thousandths. Put the square up against that little aluminum block. Bring this forward until it just touches. Lock that down. And I'm now at exactly 750 thousandths radius. I'll tighten all 3 of the set screws down. So if you remember, I want a 1/8 of an inch left on the back side where the radius will terminate. So I'm going to put some Dicom on here. I'll set my calipers to 125 thousandths. So as I'm making this radius in here, when I see the tool at that line, I know I'm finished. Now this will be a tool setup that you'll probably not see either Tom Lipton from Ox Tool or Joe Pazinski attempt. I have just a computer magnet. It's very, very clean and flat. And a piece of 125 thousandths material. I'm just going to snap that on there. Bring my tool in until it just touches. And lock my carriage down. That way when this radius comes out, it'll come out right on that line. But as I'm chopping away at it, this line will just keep moving back. And by having the line there, that when I get to that line, I know that my depth is correct also. So with the tool bit set at 3/4 of an inch, here's center. That's going to give me a 3/4 of an inch radius, and we have the setback already set. So now I'm going to back the carriage off until I've got clearance. Okay, we're about ready to cut there. So let's get to cutting. Taking about a 10,000ths cut with each pass. And you can see by having such a long handle that each pass, you can see all of the grooves in there and how consistent they are. The handle is nothing more than a 3/8 bolt and a piece of 1/8 by 1 by 1 angle iron. Okay, so now you can see by where the line is that we scribed in there, we're less than 125 thousandths to the line. So right now I've been taking cuts at 10 thousandths per swipe. So I'm going to make one pass without moving the dial and feel how much cut I'm going to get, and that will tell me how much preload, how much loading there is actually on the tool bit and how much it's pressing it back away from the work, and that will give me an idea of how much I need to move the dial to sneak up on this line. Okay, you can see how nice and smooth this will be. It'll be nothing to polish it out with a little bit of emery cloth. And it felt like I'm only taking one, maybe, probably two, maybe 3 thousandths with that finished cut. So I know when I get real close to this line, I only need to leave maybe 5 thousandths, and I'll take 2 very small cleanup cuts. So now I'm going back to the 10 thousandths cuts. Okay, right now there's just a whisper of blue. You can see the line right there. There's just a whisper of blue in there. So this is the last pass that I'm going to take at the 10,000 increment. I'm going to make this next pass without moving the dial at all, and see if I come up to that line. If I don't, I would like to go right to the middle of the line. So I'll probably only move my dial maybe 1 or 2 thousandths at a time until I get to the distance that I want. Nice. I think I'm going to take one more pass without moving the dial. Okay, so we have it. You can see how this is turned up right there, and I can just barely see the line that was scribed on there, maybe half of it. But we're done here. I'm going to move this out of the way. Let me get some Dicom on here, and we'll hit it with a flexible file and see just how smooth this is. Okay, so I did just a little bit of deburring with a file on these sharp corners so I wouldn't cut myself, as I have my finger in there. And here is what's called flexible file. You can get this in the same area that you would buy your sandpaper. Ask the guy that's at the counter or out in the aisle for flexible file. He may know what it is. So let's see how smooth this is. I would say that is very good. Just a little emery cloth. You can see how very fine the ridges are in there. It'll take nothing to get this thing just as smooth as a baby's butt. Let me get this off and I'll see you over at the table. All right then, I hope that was as exciting for you as it was for me. There we have turning the concaved die. Next, we'll be turning the convexed die that will be sitting right in there. So be sure to look at the section number 3, part 3. And that's where I'll be turning the concave die. Thanks for watching. See you later.